the National Decommissioning Centre and the launch of our marine simulator, whether you're here in person or online at the streamed event. I'd particularly welcome Professor George Boyne, the university's principal, Roger Essen, who's the head of, get this right, Industry and Partner Network for the Net Zero Technology Centre. And online we'll have a recording from Michael Matheson, Cabinet Secretary for Net Zero Energy and Transport, and also two online presentations, one from Jonathan Darby, Head of Strategic Engagement, Scotland Office, and from Joel Mills, who is the CEO of the Offshore Simulator Centre in Norway, and they were the company who contracted to put our simulator in place. As we kick this off, I'd just like to say thanks to the Scottish Government for the funding through the Decommissioning Challenge Fund that helped support this, and also to the Scottish and UK governments for the money through the ECRD, the Aberdeen City and Region deal, which also partly funded the simulator. This event is probably about 18 months overdue, and we'd kind of hoped it would be kind of April last year, and then we hoped it would be September last year, and then we hoped it would be April this year, and now it's September this year. But I'm glad you're going to make it, whether you're here in person or online. For those of you who don't know the National Decommissioning Centre, we're a partnership between the University of Aberdeen and the Net Zero Technology Centre. We launched about 2.5 years ago, January 2019, and we were set up originally to look at trying to help cost reduction in decommissioning. With the change of things over the last 2 years, we're also now straying into the areas of energy transition and net zero. So we're not just tied to decommissioning, we're looking at other things as well. And you'll find that as well. We'll be talking about some things we are doing here. And my colleague, Dr. Marston Kapitaniak, will talk a little bit about our first project, which is actually renewables. It's not decommissioning, despite the name of the centre. And at this point, I'd like to pass over to Professor George Boyne to give us our opening address. George.
Thank you. Good afternoon, everyone. It's a great pleasure to be here in person, having this discussion, and also I'm pleased that we're joined by people online. I was here about 3 years ago to help with the launch of this centre, and I think I see a few faces in the room of people who were here at that time. So you'll be aware already of the amount of work that's gone on since the launch event, the progress that the centre has made, and the strength of the partnership between this centre, both from the University of Aberdeen and other partners, including the Scottish Government and our business partners locally. And I'm really pleased with how all of this has progressed, because this partnership, this venture, reflects what the university is for. This is our purpose. We were set up in 1495, this is the history test, with the foundational purpose of being open to all and dedicated to the pursuit of truth in the service of others. And that service starts right here in the northeast of Scotland through our relationships with the organisations and the communities around us. As well as the National Decommissioning Centre, we've also established a Centre for Energy Transition in the last year, and that's conducting research, providing the first postgraduate master's programme in energy transition in the UK, as well as running short courses for managers. So we're seeing a lot of activity from the university in the energy transition space. That's exactly right, because this is, as we know, the signature topic for the North East in the decades ahead. And both the National Decommissioning Centre and the Centre for Energy Transition draw on the breadth of expertise across the university. As principal, it would be remiss of me not to tell you about a few of the accolades we've had for that expertise just in the last few weeks. So top 20 in the Guardian University UK League Table, top 20 in the Times and Sunday Times just this last weekend, University League Table, and we rose 20 places in the international rankings to be 158th best university in the world. 150th would be a bit better and have more of a ring to it, but for now, we'll take 158th. So we have a lot of expertise to contribute to this venture. We're also in a strong financial position, and we're open to co-investment with the companies and organisations around us so that we can continue to make a positive difference to economic prosperity and social well-being in the northeast of Scotland. This is our purpose. That's what we exist as a university for. I've mentioned our external partners a few times because none of this success that we achieve is possible if we operate on our own. And that partnership includes the Scottish Government. And where we're moving on to next is a recorded message from Michael Matheson.
I'm delighted to officially open the new marine simulator at the National Decommissioning Centre. My thanks go to Professor George Boyne and the team at Aberdeen University for the invitation to speak to you today. The partnership between the Net Zero Technology Centre and Aberdeen University is crucial to supporting the oil and gas industry to develop and deploy technology to accelerate the transition to an affordable net zero North Sea. The development of the new marine simulator is an example of our efforts to ensure Scotland's world-class supply chain has the infrastructure required to remain competitive and become a centre of decommissioning excellence. The Scottish Government has invested over £4.5 million in the National Decommissioning Centre through the Decommissioning Challenge Fund. In addition, as part of the Aberdeen City Region deal, we are supporting the centre with a contribution of £90 million over 10 years to the Net Zero Technology Centre. This new technology will help us build our global reputation for carrying out decommissioning to the highest safety and environmental standards, minimising the risk to the environment and other users of the sea. With a market forecast of over £15 billion in the next decade, decommissioning presents huge opportunities for Scotland. Although COVID and the oil price crash have caused delays, decommissioning spend is forecast to increase over the next few years, reaching an estimated £1.8 billion next year. That's why, over the past 4 years, the Scottish Government's Decommissioning Challenge Fund has awarded over £12 million to 38 projects, helping to build Scottish skills and capacity to undertake decommissioning. Decommissioning is, after all, part of the natural life cycle of oil and gas operations and will be an integral part of the transition process. The new marine simulator is a good example of developed for oil and gas decommissioning, but has multiple applications in areas such as offshore wind and even city planning. The actions needed to become net zero by 2045 will transform all sectors of our economy and society. This kind of innovation will be essential to create a resilient, greener, well-being economy. The commercial opportunities in the energy transition are vast and we are already making significant investments. For example, we are investing some £62 million through the Energy Transition Fund to projects such as the Global Underwater Hub and the Energy Transition Zone, £180 million in the Emerging Energy Technology Fund to support innovation in technologies like carbon capture, utilisation and storage, and hydrogen. £100 million as part of a Green Jobs Fund. And over £14 million in the North East Economic Recovery and Skills Fund. We know that sectoral and geographic challenges exist, and having also committed some £500 million to a new Just Transition Fund for the North East and Moray over the next 10 years. This will help to position Aberdeen and the wider North East as one of Scotland's centres of excellence for the transition to a net zero economy. The recently announced programme for government sets out how we will secure a green economic recovery by capitalising on Scotland's strengths in energy, natural capital, innovation and skills, we can position Scotland at the forefront of growing global markets across the energy system, including in decommissioning. This has never been more important as we look to showcase Scotland to the world during COP26. Scottish people and businesses have shown that they can do it in times of adversity. The openness to change and adaptability is to be applauded, and I look forward to this spirit of cooperation, collaboration and innovation continuing through projects such as this. Thank you, and I wish you well with your conference.
I'd like to again thank the Scottish Government for the support and for Michael Matheson for his video talk at the moment. At this point, I'd like to hand over to my colleague, Roger Essen from Net Zero Technology Centre.
Thank you, Richard. And I probably, as well, more than many people here, I'm delighted to be standing here today, 18 months, as Richard says, later than we had originally anticipated, but being able to stand here today and talk to you about our co-investment in the marine simulator at the National Decommissioning Centre. And for many of you who I have met over the few months while we've been working from home, will realise that I've mentioned unashamedly in almost every single conversation the capability that we're building here at the National Decommissioning Centre with the marine simulator. And it's great to have you here today, because hopefully in being able to take you through and see the facility here now, you'll be able to fully understand the opportunity that we collectively see in being able to simulate not only decommissioning in the North Sea, but the transition to net zero and the opportunity that that presents for our industry. Decommissioning is always going to be a key part when we set out on this journey, and we looked at the marine simulator. Decommissioning and the simulation of individual projects was the priority. How do we use this technology to virtually prototype new technologies? And two of the developers that we're working with are here today, and you'll be able to see in the simulator the activity that we're doing in that space. But as we move towards net zero, as we move towards the Scottish Government 2045 targets, the UK Government's 2050 targets, and indeed Roadmap 2035, which OG UK is leading on behalf of the industry. This is a tool that will enable us to be able to tell the story and demonstrate how our industry is moving towards that net zero future and the integrated energy system that we can create in the North Sea. In fact, the numbers that the Net Zero Technology Centre published late last year suggest that the value of energy in the North Sea is set to nearly double from 2020 figures through to 2050. And oil and gas continues to be an important part of that mix, but clearly getting towards that net zero future and how that integrated energy system comes together. We have a fantastic tool here, unique in the northeast of Scotland, and be able to build that capability to show how we're going to lead in the energy transition. Richard, I'll hand back to you.
Thanks, Roger. Again, I'd just like to thank the Net Zero Technology Centre for their support. And actually, I'd like to thank somebody else in the audience at the moment. I'd like to thank Russell Steenson for some of the vision that he had for setting this up as well. So thanks, Russell. At this point, all being well, if all our networking has worked out correctly, we should have a dial-in call from Joel Mills, who's currently sitting in Stavanger. But Joel is the CEO of the Offshore Simulator Centre, who supplied the simulator itself. So I'll pass over at this point to Joel.
Okay, hello. Thank you very much for letting me join you. I wish I could be with you in person. It's a real shame I can't be, but we're really pleased and proud to be able to deliver this technology to the centre there. And we're very excited about the opportunities it will open for cooperation in the future. But today I'm going to talk a little bit about the simulation technology we're using in other areas. I'm going to take you through a presentation. So I hope you're able to see my presentation. And I'm going to take you through a presentation where I talk a little bit about how we can use this simulation to compress time through disruptive technologies. So as you've seen, and you'll see more of as you get to go in and try out the dome and see the demo, we know, and we've been working for many years on delivering the world's most leading technology for the offshore and maritime and oceans environments. And this is used throughout all the different areas, if it's from oil or gas or if it's through renewables. Anything we've been working with is really the idea of how you interconnect humans and machines. Machines are amazing at data processing, and they're going to get better and better at processing. But humans are absolutely unbelievable at understanding data and working with data in a visual format. We are 1,000 times faster at processing data in visuals than we are in text, and we can really start to understand things in a different way. The image you see in the middle on the right-hand side is showing a machine trying to understand data through artificial intelligence. The machine is struggling to understand the difference between just vehicles. I can pick out within a few seconds the colour of somebody's shoes or what jacket they're wearing without even thinking about it. If we can put this power together of machines and people together, we can really be a disruptive bridge which will allow us to compress time and solve the problems we have in front of us in a much faster way. So an example of this outside of the offshore world is where we started to use this for cities, and we've started to be able to understand how we can look at stuff. So we took the data from the offshore, from the fire brigade, and put this together with all of the response times and the traffic for a city. And we saw how today the vehicles are responding in 15 minutes. It's responding in 30 minutes, sorry, but with a few changes that we could try out in the simulation without changing the infrastructure dramatically, we could change this completely and half this down to 15 minutes. So I'm going to show you a short video to explain this.
Let me tell you a story. My dad used to be one of those stressed policymakers. You see, my dad was afraid if a fire were to break out during rush hour, it will be impossible for the firemen to make it in time. And then one day, my dad met this guy who had this really cool technology. This guy showed Dad how he could upload all his piles of existing data to map the effects wind, rain and temperature would have on the fire. You could even solve traffic jams by knowing what people were needing and changing opening hours of kindergartens and schools so that the fire trucks could pass. Suddenly, my dad was solving so many of those policy issues that he felt a little bit like a superhero. No, not like that, Dad. Luckily, the slow fire hours has been another simulation. Okay, guys, let's do it one more time.
Hologram program activate.
So the idea of this is we're trying to make high-level, detailed data into child's play. We're trying to make it something that anybody can understand and work with. And we're using exactly the same technology that we've been using in ocean and offshore to do this. And we've come into partnerships. So we've been chosen globally as the United Nations technology partner for their Sustainable Cities Programme for the Future, really understanding how we can bring this data into humans to make those decisions and to really speed up time. So if we look at this, we can see that this is the system that 17 of the UN agencies have come together to create, and they have created a KPI system to analyse a city, to look at 92 indicators to understand where a city is doing a good job and where they're not doing such a good job and what changes they can do. We've taken these KPIs directly into our simulation world, and we can bring them in, and I call it a lollipop, where we place them directly into the middle of the city, and then we can drill down into any of the data sets and see where the city is doing well, where the city isn't doing so well, and how we can make changes, and we can test out these changes. And it's really about getting to a point where we can build up and understand the DNA of a city, understand exactly what makes the city work and how all of these parts interconnect together to make those solutions. So we can look at the building efficiencies, we can look at the transport network, we can look at the way people flow, we can bring in any data which has a geolocation, we can bring in there, and we can start to visualize that and start to work with that to test out scenarios so we can, as I said earlier, speed up time to get to these solutions. And we are creating these large simulation solutions, and we have them around the world. You see some of the pictures from my office here and one of the ones we're talking about in Montenegro, but it's different solutions we have down around the world here. And it's about bringing people into this environment. We can do it just with a screen, but we can also take it into these large environments like you have there in your centre in Aberdeen there. So a big focus for us has been also looking directly at net zero and how we get to net zero and what are the big contributors to net zero. So 80% of all of the CO2 created comes from cities, and over 50% of that comes from buildings and mobility. So a big focus for us has been mobility and energy from buildings, but we can use this in any area we want to. And once we've done this in one city, we can just copy it across and make it for any other cities we want to. And we already have a full, complete digital twin created of the city of Aberdeen and a number of the other cities within the UK. And today, I think we've got most of Norway mapped into the simulator centre. So we've been doing, not just using this for understanding data sets, but doing real projects and solving real issues. And I'm just flashing up some images here of some of the projects we've been working on. It's been projects from schools, been hospitals, been total transport network. It's been understanding how we can bring in many new people into a city. It's looking at smart solutions for mobility. It's understanding the CO2 created from vehicles. And it's loads of different projects where this is actually making a real difference and already showing amazing return on investment with using this software to speed up time and test things out in a safe simulation environment rather than having to do it in real life. So I've just put in an image here right at the end to show you into the dome, but I guess you're all going to get to go in, or at least some of you to get to go in and actually see the dome today. And if you don't get to see it today, I really encourage you to come back another time and go in and actually get to play, because of however much I can try and present over the net here, you'll never really get the feeling unless you're standing in the middle of it and absorbing yourself into that data. So for now, I want to say thank you very much. I hope you have a lovely rest of the day, and I hope it's a really good opening. So thank you for now, and good luck.
Thank you, Joel. Just like thank you for. I'd also like to say that I actually asked Joel to highlight the kind of smart city side of things, because one of the presentations that Martin and myself will do is covering the kind of marine simulation side of things. And I thought it was quite important to see this is not just a marine simulator. This is a much wider application. So at this point, I'd like to hand over to our next speaker, and our next speaker is Jonathan Darby. He's Head of Strategic Engagement for the Scotland office, and all being well, Jonathan should be online at the moment, and I'll hand over to him. Jonathan.
Good afternoon. The Office of the Secretary of State for Scotland is delighted to be here today, albeit virtually, to join the National Decommissioning Centre as they launch their new simulator. This impressive and real-time simulator will model North Sea infrastructure and help to improve decision-making across the oil and gas and renewable sectors. This really is a remarkable new system, and we are looking forward to seeing the beneficial effects it has on the industry. Following the pandemic, achieving a green recovery, building back better and levelling up across the UK are all key priorities for the government. We believe that the national decommissioning sector and supply chain can play an important role in these. But firstly, I wanted to briefly mention some significant policy announcements which demonstrate the UK government's commitment to achieving its net zero ambitions, whilst supporting the oil and gas industry in Scotland and the wider UK as it transitions to clean energy. Firstly, the Prime Minister's 10-point plan announced in November last year will support up to 250,000 jobs across the UK, demonstrating the government's commitment to a green industrial revolution. The plan makes significant commitments across the renewables sector, such as offshore wind, and in developing technologies and markets, such as carbon capture and storage, hydrogen, nuclear, marine and clean transport. The plan will mobilise £12 billion of government investment and spur up to 3 times as much private sector investment by 2030. In December, the Energy White Paper set out a domestic agenda for tackling climate change and reaching net zero. And that included the successful conclusion of negotiations with Oil and Gas UK on a North Sea transition deal. And This partnership between government and industry and the regulator aims to drive our shift to low carbon energy while supporting the workforce, supply chain companies and communities on that journey. The deal supports up to 440,000 high-quality direct and indirect supply chain jobs in decarbonising UK CS production and hydrogen sectors. And this office is particularly pleased that the Chancellor has also announced additional funding to support jobs and green growth in Scotland in the March budget, with specific measures announced for the oil and gas industry, which came on the heels of the industrial decarbonisation strategy, a package of green measures set to make the UK net zero by 2050. So the government is clearly demonstrating its commitment to green recovery by continuing to support the oil and gas sector in its transition to clean energy and by investing in further new innovative technologies and the expansion of the renewable energy sector market. But in doing this, it is of course important that we continue to remember that we cannot transition from oil and gas without the oil and gas industry itself. And we need to continue to work to maintain that productive partnership as we face together the challenges ahead. Going back to decommissioning specifically, in December 2020, the government published our response to the call for evidence on decommissioning. This articulated the clear opportunity for the industry in the global market, worth around £80 billion in the next decade, and over £250 billion from 2022 onwards. It's the government's ambition for the UK that we are able to capitalise on the sizable market opportunities available within UKCS and the wider North Sea, and use this to the advantage to become a global decommissioning centre. Colleagues in the Department for International Trade are working with government, regulators and export agencies, as well as the industry itself, to develop a global oil and gas decommissioning export strategy, to identify specific overseas opportunities and promote the UK decommissioning expertise. It will identify exportable UK strengths and set out specific, achievable and measurable targets for the industry. And domestically, the sector clearly has the assets, expertise and capabilities to deliver on the government's ambitions for clean energy. There is clearly a wealth of knowledge, experience and skills in decommissioning, which are both transferable and transportable between industries and exportable worldwide, in areas such as well plugging and abandonment, waste management, project consultancy, to name but a few, and this is globally recognised. Clearly, as a government, we are investing a lot to support the energy sector as a whole and the oil and gas sector specifically, but we recognise there is more to do. We need to accelerate progress and build on our success if we are to meet the net zero targets. We need to continue to review whether our energy networks and markets are operating efficiently and facilitating the transition to clean energy that we all want to see. And we need to ensure that our regulatory frameworks are fit for purpose, both now and in the future. And we need to ensure that we drive. We need to incentivise and support consumers to make optimal choices which benefit our environment, including making low carbon choices when it comes to heating their homes and places for work. All of which means that we will continue to work with the Scottish Government in areas such as heat policy, energy efficiency and other areas for which they are responsible. Finally, I could not end without mentioning that it is now less than 7 weeks to go until the UK government hosts the United Nations COP26 conference in Glasgow. The conference will be a crucial opportunity for all parts of the UK and all nations globally to work together to create a cleaner, greener and more sustainable future. And we are working closely with the Scottish Government to ensure an inclusive and ambitious summit for the whole of the UK. I'd like to thank you for the invitation to join me this afternoon and wish you best for the rest of this afternoon. Thank you. Bye-bye.
Thank you, Jonathan. At this point, I would like to give you kind of overview of what sits about 10 metres that way before you get a chance to play around with it later on. So if I can ask Richard at this point to load up the video. I'll speak first and then Martin will talk about one of the first projects we've actually got with the simulator. And I'll try and describe a little bit about its capabilities first. We've got three main areas in the simulator. We've got the dome with real-time controls, we've got our control station, and we've got our debriefing room. And we're going to start off in the control section. So this is our main control station, and this is Martin sitting there. This is where we'll build the simulation, we'll build the scene, and we'll bring in vessels and cranes and ROVs and other items from what's called the sandbox. The three stations you can see in the background here are additional control stations where we can have people working to change things within the simulation while other people are doing the simulation in real time. An example might be we might change the weather conditions or the sea state and see what the effect of that is. And we've got the debriefing room where we can rerun simulations, discuss them, and if we need to just talk to more people, we can actually display on the large screen here. So moving into the dome. Dome is our main real-time control and visualization space. And it has 4 control chairs. So these are 4 control chairs with real-time controls. 2 of these can control vessels and 2 can control either cranes or remote operated vehicles. And this system allows us to trial items in a virtual safe environment. So the chairs allow us to operate and trial things out without having to deploy them. So we're going to show two examples at the moment of the system running. This is a lift from a subsea. So the piece of equipment here you can see is based on the Stress Space subsea manifold. So this is a subsea lift from a vessel. So we've got coming off the seabed here. So we've got a vessel with what's called a knuckle boom crane. So we're lifting right from the seabed up and we're going to deploy on the deck. And this is, I've talked about this, it's got real-time physics in it. So actually, we'll see in a second when this comes through the splash zone, we'll see some of these physics. So you can actually see the rocking of the things that comes through the splash zone. And when the crane moves round, again, we'll get some of that motion. So this is all-time, real-time physics. For this particular simulation, we've actually tried to put this on the back of the deck of the boat. That's really quite challenging. It's very, as you can see, it's quite tight for space. But to show some of the flexibility of the system, we can rerun the same simulation. So this is part of that simulation. We've lifted the manifold out of the water, but we can now bring in a barge in real time. So this is Martin actually doing some of this work. We've pulled in a barge from the sandbox. Once it's into the simulation, we can position it. So at the moment, all of these things are still running. We can move the cranes, we can move the vessel, we can pull the barge in alongside the vessel. We can then bring a tug and connect that up to the barge. So when we're moving off, we can then load off onto the barge. And once the cable connections have been taken away, we can then drive that away. So this is all real time. We can pull all these things together and put them together. We're also partnered with a company called Axelos to provide some fine element analysis. And we're in the stage of interfacing the two systems, and we're using the manifold as an exemplar. The other simulation we've got here is EIP's ambient lifter. And this is a simulation of taking out a piece of conductor from a jacket. So the ambient lifter varies buoyancy to take the weight, and then we drive the ROV and the ambient lift system out through the jacket. So this was done in all real time in the dome. And we transit down then to a basket, which is down here. And the system can then latch onto that, deposit the piece of conductor into the basket, and that's then recovered back to the surface. So this is speeded up, but because otherwise you'd be sitting here for 10 minutes watching a thing moving slowly. But we can then recover back onto the back of the vessel. Joel talked a lot about the smart city side of things. We're going to use that. Our main thing at the moment is to look at how we utilize the system for energy transition campaigns, how we might integrate renewables with offshore oil and gas. Our primary project at the moment is a thing called Smart Basin, and the aim of that is to try and map out the whole of the North Sea, all of the infrastructure, oil and gas and renewables. And to do that, we'll use things like the Oil and Gas Authority's National Data Repository, but we'll also tap into other sources. And the idea would be to include things like COP dates, cessation and production dates, renewables and when they're going to start up and what the capacity might be, maybe CCS, and then try to make better decisions across the basin. So rather than doing it by asset, can we do things in a different way? And we started this at the moment with an exemplar area, which is actually east of Shetland. So we're at the moment, we're building the asset for that. OSC are helping us with that. But the idea is we'll then move to the southern North Sea. Northern North Sea is very interesting because we've got potential for connection to Norway, but we'll then move down to southern North Sea where there's potential for integration with renewables. So to give an idea of this in more accessible scale, Joel mentioned we've got a model built of Aberdeen, and at the moment we're collecting data which we'll be able to superimpose on that. The first project we're hoping to run on this is a collaborative study between the Aberdeen City Council and the Harbour Board, and it's going to be looking at the traffic flows around the new South Basin. We've got the North Basin here as well, and we'll be trying to extend to map out the whole of the harbour area. So that's the first thing that we've got at the moment. So we've started discussions with the council. We've had really excellent support from the Harbour Board. And at this point, I think I will close off and I will pass over to Marcin Kapitaniak, who's our simulator technical manager, who will give you a little bit of a flavour of the first project we've got. And as I say, the first project is actually not decommissioning. Marcin, over to you.
Thank you very much, Richard. So let me just introduce you to the first project that we've got into. It's in the field of renewable energy. And in this project received funding from EPSRC Supergen Offshore Renewable Hub and Floating Offshore Wind Center of Excellence. And we are addressing the need for development of novel, more cost-effective and more efficient methods of installing offshore wind farms. And in this project, we'll be using the NDC simulator to conduct virtual field trials of pumpable buoyancy technology and underwater lifting system for installation of wind farm anchors in particular. And during the virtual field trials, we will consider all the environmental conditions and observe the effects, for example, of the sea states on the plant deployment scenarios, and try to assess the technology and its applicability and also the feasibility of the proposed deployment scenarios. As a first kind of test case of the plant deployment scenario, we are considering a new type of floating anchor, which will be deployed from a support vessel and originally to be towed to the site and then deployed from the small support vessel, which will be much cheaper to rent as well. And the vessel only needs to be equipped with the winch and the hose reel, and we will be pumping the ballast fluid into the anchor to allow it to sink and position itself directly under the stern of the vessel, which in turn will allow us to adjust also the desired position by moving the vessel. And at that point, the weight of the anchor will be supported only by the winch cable, and then the operator will enable the winch and start the deployment process, allowing the anchor to sink by its own weight down to the seabed and only guided by the winch cable. And once the anchor will be in close proximity to the seabed, we can then deploy, for example, an ROV that can do fine-tuning and final adjustments in the position and orientation of the anchor for final installations. And throughout this project, we hope to basically establish the effects of environmental conditions on the plant deployment scenario and compare it to the standard methods, for example, deployment using a crane, and establish the benefits of this approach in terms of reduced cost and reduced carbon footprint. Thank you very much.
So it's actually quite nice that actually our first project is not decommissioning, it's actually renewables. But we have some, we do, just so we're not mis-selling ourselves in terms of national decommissioning, we do have some decommissioning projects in the pipeline for this as well. So at this point, I'd just like to say thank you to all of those who've taken part, to George, Roger, Michael Matheson, Jonathan Darby, Martin, and I've forgotten something, Joel. And just close out this point. So I also like to thank the NDC team for putting this together, Jill and her team at the events. Richard and Colin for all of the work they've done in terms of actually making this work seamlessly in terms of the technical side of things. So I'd just like to thank all those who've made this a success today. At this point, we'll split the live stream and the in-person event. So those of you who are here and have the advantage of being that, we've got some time to do a bit of networking, and we'll take you through in groups to see the simulator. To those of you who are online, I think we've got a question and answer session set up, and we'll pass over to that team. Thank you.
Good afternoon, everyone, and welcome to our online Q&A session. My name is Karen McCardle. I'm the Centre Manager here at the National Decommissioning Centre. I'll be your host today for the Q&A session, which should last approximately 30 minutes, but we may carry on if we get some good discussion going. I hope you enjoyed that last session that marks the launch of our marine simulator. And that has inspired you to ask some interesting questions. Now is your chance to find out a little bit more about the simulator, whether it be on the technical aspects, exploring the benefits to the Decommissioning Centre a little bit more, or looking at how the simulator can support energy transition projects. So now is your chance to ask questions. I'm delighted to be joined by 3 panel members today, who will do their utmost, I know, to answer all of your questions. So I'd like to welcome first Sergey Arono. Sergey is our Project Delivery Manager here at the National Decommissioning Centre. We then have Pamela Lamoro, who I'm sure a lot of you know. Pamela is Project Manager at the Net Zero Technology Centre and supports us here at the National Decommissioning Centre. And last but not least, we have Craig Nicholl, who is also a Project Manager at the Net Zero Technology Centre and focuses on decommissioning. So welcome to all our panel members. I think at the moment when we are waiting for some questions to come through, we may as well get started, and I have a few questions myself here. So I'm going to direct this one at all of the panel members. So what do you think, and I'm going to ask this to each of you, is going to be the single biggest benefit or transformation of this technology, our marine simulator, to either the decommissioning sector or energy transition projects, or both? So I'm going to start off with, and I'm going to direct that at Craig first.
Okay, I get to go first, so you guys can copy my answer. That's good. Thank you, Karen. I think this. I think the most exciting part for me is the emerging technology simulation capabilities. So not just in a marine transport environment, etc., but new tech that's on board these. So lifting techniques, cutting techniques. We're looking at subsea technologies as well, and how that can be integrated without having to build physical prototypes. So effectively do a sense check and an initial simulations to check the viability of it. But then that rolls into seamlessly into the smart basin program that's ongoing as well with it, which I kind of deal with as a separate entity. That it gives a really informed decision-making process if you've got the holistic view of the activities within the UKCS. You can plug in COP dates or electrification requirements of platforms, etc., and look at it in a holistic view rather than an operator insular way. So there's lots of exciting stuff, but looking forward to get going with the technology. I think first is what would get my vote.
Thanks, Craig. Pamela, I'll go to you next.
Yeah, certainly. All that Craig's mentioned is absolutely correct. And just to add to that, I think it offers the capability or the ability to be able to unlock barriers to data sharing and manipulating a sort of a humongous volume of data that we can't possibly process using current technologies in the way that we can using the simulator. I think one key thing is also that it will demonstrate an integrated energy through the integrated energy basin approach. It will enable innovations and anchor the supply chain by offering visibility of the work scopes that are currently in the market, or the work scopes that can be available to the supply chain. And also, I think it will then demonstrate the opportunities for new collaborative ways of working. So, for example, through decommissioning campaigns where we can visualize and see who within which areas of the basin are working in the same sort of scope, and how that can be there can be a collaboration between those. And last but not least, I think it will also facilitate knowledge sharing, because it's not just limited to the capability within the energy industry, but or the oil and gas industry, as we've seen, being able to interact with the fisheries industry, being able to interact with the transportation and logistics industry. I think that offers infinite possibilities. So it's exciting times.
That's super. Thank you, Pamela. And Sergey, to you. You're on mute, Sergey.
Thanks, Karen. I'm going to talk from a planning and decision-making point of view. We are living in a world in which data is being generated faster than the human mind can process. So in this context, the question should be, how can we help the human mind process this huge amount of data being generated? The simulator provides a visual environment allowing the representation of data in different visual formats, such as 3D models, interactive graphs, heat maps, and so on. And the human mind is very good at processing visual data, which in turn can help a better planning and in making better decisions.
That's great. Thanks so much, Sergey. So now I'm looking at our Q&A panel here, and I see we have a little bit of a technical question, I would say. So I'm going to direct this one at Sergey. How long does it take to model a large steel jacket in the simulator?
Thanks, Karen. Yeah, so we can import a CAD model into the simulator. That's an easy job. The difficult part is giving the right physical properties to the CAD model. So we would have to look at this on a project by project basis, really.
You're muted, Karen.
Apologies. If anyone in the panel wants to chip in, please feel free to do so. So next question. Is it envisaged that the simulator will be used to support decom options required for comparative assessments?
Yeah, I can add my comments to that.
Excellent. Thanks, Craig.
I think it's twofold the way I see it moving forward. The actual physical operations through the optioneering of decommissioning projects. So the selection of technology, so different barges, different lifting methods, etc., can be played out within the simulator. That's one thing that can be really used as a comparative assessment, but possibly a level higher than that. The Smart Basin program could also be used to plan vessel locations, capabilities, possible bottlenecks in supply chain, because it's got the holistic view of all the activity that's going on, you know, asset owners can look at opportunities for co-action of a vessel. So it would map that a certain vessel was in the area for not only decommissioning, but it could be for construction or renewable installation, etc. And then tie it in with, you know, with what we've called internally as a milk round, but rather than paying for large mobilizations of these vessels from their native ports, it can stay in field and do a few jobs at once. So I hate to use the word, but collaboration would be achieved there. But yes, so, yeah.
That's great. Thanks, Craig. Pamela?
Yes, just to add to what Craig's saying, or rather to elaborate on it, I think also furthermore, these capabilities to visualize scenarios can really highlight synergies between existing and potential energy assets. So also, for example, looking at electrification, oil and gas reuse and repurposing, and renewables. So the reuse and repurposing optioneering is for, you know, decommissioning assessment is going to become more and more of a bigger feature than we're seeing at the moment. So that's something that we are already looking at in the centre. We've recently acquired government funding to look at data for net zero and how we can accelerate the transition to net zero through reuse and repurposing. So I think there is infinite possibilities. Basically, it's as imaginative as you can be. There is very little limitation to what scenarios you can plan in the simulator.
That's excellent. Thanks, Pamela. We'll move on to the next question. And this is a good one now. So the simulator is badged as a marine simulator, whereas we've heard that the technology supports onshore too. To what extent is there an opportunity to extend this instance of the tool to cover decommissioning of onshore assets beyond harbours? Now, any takers? Sergey, how do you feel about looking at this question? So we have focused very much on the offshore. Where do we see it maybe being used for onshore decommissioning activity? Modelling scenarios, for example.
It's a good question. Maybe I will ask some of my colleagues to help me with that, but I can mention some of the data that we can visualize in the simulator, and that would be satellite live data such as traffic and weather, and how the layout of the streets. So I guess all these, if we could have access to all that data, would help with decommissioning onshore.
Yeah, but I think the primary focus at the moment of the centre is on marine activities, as well as you know, supporting, you're saying, extending past harbours, because we are very focused on modelling the harbours and ports, because that does encompass the marine world. But for an onshore point of view, I'm not sure that has been a focus of ours to date. I mean, it would be an extension of this technology, but at the moment, our main focus is to add benefit to the UKCS.
Yeah, just to add to that, absolutely, Craig. We are already working with Aberdeen Harbour to as Richard mentioned in his presentation, and that's just some extension of that work, you know, looking at ports and harbours capability and transportation and traffic. Obviously, this tool has been used, as Joe mentioned, as a primary tool for the UN system to map cities, and it's based on that. So while it's not our focus, it's not impossible to do that. At the moment, it's not the focus of the centre to look at that, but we're not limited.
That's excellent. Thank you all. Now, here's a little bit less technical question, but a very important one. Any perceived impact benefits on insurance and liability side of things with regards to trialing an operation virtually before doing it for real? So I'm going to, Craig, let's start with you.
Okay, yeah, simple answer is no. It's been a bit of a hot topic, but effectively the way I would word it is it's a knee up for developers to effectively strength test the capability of their technology or a methodology in a marine environment with real-time physics. That's never going to be enough, I don't think, unless the virtual world becomes an awful lot more robust. It's never going to be enough to change the impact of insurance and liabilities, etc. That's certainly not the position we're in at the moment. However, it does give a level of assurance, and like I said, not to repeat myself, a knee up to give these developers the confidence to then go and build a real-time prototype to field trial. It also gives a huge amount of confidence to push the boundaries a little bit further with the technology and the capabilities of it before. So a higher risk technology coming into the marketplace could be realised within a simulation that otherwise a company wouldn't have had effectively the confidence to hedge on a risky technology. So hopefully it's going to bring on some of the more weird and wonderful ideas that possibly would never have got off the ground because of the assurance. But no, it has been a question that has been asked many a time already with the insurances and liabilities, and I don't think we're there yet. But never say never.
Yeah, just to add to what Craig's saying, I think I have to slightly disagree. I do think that there is a possibility of this becoming a tool that can be used to reduce insurance liabilities. Specifically, while we do not have that capability right now, we're looking to work with Askelos, for example, to look at structural deformation. So while it's not an FE, it does not have an FE capability, we are looking to incorporate something similar that will enhance that feature, and therefore to be able to give an accurate scenario as possible. And the fact that we're able to do that in a very quick time turnaround, and to be able to incorporate so many different types of conditions, whether it's weather or all other conditions, into the system, to be able to really give an indication of the behavioral output that could be achieved, I think that could lead to some of the reductions in insurance because of that. So while we do not have that capability right now, we are working on it, and we are confident, I think, that could be a feature that going forward.
Okay, thanks both. We'll move on to the next question. With the increase of digital twin technology, can the NDC Marine Simulator simulate different scenarios for platform removal? For example, piece small, single lift with consideration to weights and vessel lift capacities. And I'm going to go to Sergey just to, unpack that a little bit more.
Yeah, thanks, Karen. Yeah, so I'm going to tell you a bit more about the physical engine behind the simulator. The physical engine behind the simulator is a multi-body and multi-domain dynamics engine supplied by Algorithms. And we use the word multi-body because it can simulate different objects with contact and friction. And as a result of this, we can simulate geometrical interference during a lifting operation and check if the structure being lifted will collide with other objects within the simulation, for example. And and I'm going to give another example. We could simulate a narrow beam intervention and check for potential umbilical entanglements with other subsea structures. But we also use the word or the concept multi-domain dynamics because we have the capability to simulate different aspects such as environmental loading, that would be waves, currents, and winds, and hydrodynamic and hydrostatic pressures, drag force, as well as tension and deformation on cables and wires. In other words, we can couple the effects of waves and the dynamic loading on cables and wires during a lifting operation, for example.
You're muted, Karen.
You're muted, Karen.
Here we go again with the mute. Sorry about that, everybody. We'll move on to the next question. So I think I might direct this one to Pamela first. So what order of magnitude savings do you think the utilisation of the NDC marine simulator would have on real decommissioning removal projects?
Wow, thank you very much. Now it's difficult, of course, to quantify that because it will depend on the exact project we're talking about. But definitely the savings will come from the issue of de-risking, the issue of improving efficiency in the technology by modeling scenarios, and of course in timing. So it's prototyping, enhancing design and prototyping without having to put it out there into field trials immediately. So you could do all that on the simulator and actually enhance your either product design or scenarios or technique or operations prior to actually trialing it out in the sea. So there are cost savings that could come through the process itself, and cost savings that could be made through the enhancement to the project or the project feature. So it's very difficult. While it's very difficult to say specifically because it depends on the type of the project, but we envisage that millions of pounds literally could be saved, just based on current processes at the moment.
Thank you, Pamela.
I to that as well. If I'm glad Pamela got the millions of pounds figure out there. I was nervous. I was nervous to put a figure on it, but we do envisage that it could have a huge saving, both in a commercial way and a safety way as well. But I will just add to that, we've actually got a few projects in the holding pen, should we say, at the NZTC, ready to go, and they are very, very different, but very, very decommissioning centric. So the first one is on a concept with reusable grillage, which opens up a whole multitude of things. I won't go into too much detail in the Q&A panel, but it opens up different ports, different removal strategies, etc. And it's very, very geared up. It suits the simulator very well because we're hoping to simulate different scenarios of removals of multiple platforms, whether it be differing geographies, weights, structures, etc., and how we can effectively play tunes with the norm to date, and see what changes that would do for possible bottlenecks in the supply chain, like we say. So disposal yards are at a premium. If you believe the bow wave of decommissioning projects that's coming in the next 5 to 10 years. So how do we smooth off that curve? So the reusable grillage is one. We've also got some informed decision-making process projects that again are in the pen, waiting to go, which we're really excited about doing as well. So we're going to be doing a big rollout to market and the supply chain, and so we urge you to get in contact if you want to get involved. But we will be coming to you also as well, because there's one thing having the tech and having the simulator, but we need to make sure that we're answering and simulating the correct problems and questions that are out there. So we really need interaction with the outside world.
Thanks very much, Craig. Yeah, we're getting some very nice questions coming in. So this is one I will definitely be directing to Sergey, and it's a lovely question. Absolutely brilliant project. As an ecologist that works with engineers via the EPSRC SuperGen ORE hub, we are promoting the whole system approach in planning, especially for floating wind. So wondering how well the simulator would deal with some reality of adding other users of the sea, such as fishing industry interactions, differences in benthic and pelagic habitat, for example, sand versus mud, mixed versus stratified, and mobile animals, such as distribution of fish, seabirds, and marine mammals.
Yeah, and I think this is why the simulator is built for, to integrate all these different aspects and not just the engineering part, but different sets of data that in a normal situation we would have to spend days and days reading and going through reports. So if we can gather all the same information all this information in the same platform, and then we would be able to take better decisions. Absolutely. Yeah.
You're muted.
Just to add to that, we currently, as part of just to add to that, as part of our D4 Data for Net Zero project, which has recently been awarded through the Scottish Government, we're working on work packages such as fisheries, spatial portal data, which is looking at offshore wind, and also looking at workforce in the offshore, looking at all the other systems that are not necessarily oil and gas, but interact with oil and gas and renewable energies. And we can be able to map those out in our smart basin, which is a concept in which we look to map the entire UK continental shelf, starting with discrete assets in discrete regions, and to be able to map all the users of the sea that interact with the energy systems, whether it be oil and gas or renewables. So absolutely, this is something we're already starting to work with as part of our Data for Net Zero.
Lovely, thank you both. Next question. So has the NDC been talking to the Scottish Cities Partnership to share the capabilities of the system? Seems like a great tool for the cities to collaborate on a net zero modelling project. Pamela, you're shaking your head, so I'm going to go to you first.
Okay, well, okay, and as far as I'm aware, there are conversations ongoing. They're still in the initial stages, and absolutely there are people from far and wide industries and sectors who are interested in the simulation suite. And we have to say that this is the first of its kind in the northeast of Scotland, and possibly the first of its kind with this specific capability in the UK, according to our partners at Offshore Simulation Centre in Norway. So we are inundated with so many partners looking to use this simulator, but obviously our priority is to make it a marine simulator, and looking at the energy basin and looking at the energy interactivity. And these other applications are secondary, but we are looking at that and having these conversations. Certainly, as has been mentioned already, with the Aberdeen Harbour Board, we're already mapping the board and the traffic around those. So yes.
That's excellent. I am looking and keeping track of time. I think we probably have time for maybe 2 more questions, but don't worry, we will try and get your try and answer your questions after the event. There's some very great questions coming through. So here's one I think I will direct at Craig. So has there been a positive feedback from the decommissioning sector for the simulator approach, i.e. prepared to add this approach to their suite of planning tools?
Yes. There has been. It's early stages with it being added as part of the toolkit, an official toolkit, so to speak, but we have a lot of operator support, having already given us their models to allow us to model in to the simulator, and to start using that as the first projects that we move forward, some example projects, etc. But moving forward, it's very much it's going to grow organically once you see the benefits of the first few projects. I'm a firm believer in that, and more operators will get involved at that stage. But I think it's a very positive start. East of Shetland area is nearing completion, and we'll hopefully work our way down, but down the basin and have the whole whole North Sea modelled as an aspiration within 2 years. So yes, it's all about the participation of the asset owners, but it will become easier when we can show them the benefits that it's going to give them.
Yeah, just to add, I don't know if you can hear me. Just to add to what Craig is saying, we are, as you know, as you're aware, Karen, already speaking to a number of operators in supply chain and also people from the marine environment with regards to potential projects, what we call pipeline projects for the simulator. So we already have a number of mature discussions ongoing, and these will materialise. And as Sergey mentioned, we also have the EPSRC project and the D4NZ project and the Smart Basin, which is all encompassed under the Smart Basin project. We're talking with the OGA to look at how we can unlock data sharing. We have here a project that looks to provide a safe haven for a data platform which we will use as a complementary tool to collect data from industry and anonymize that data, so to give industry the confidence that we will hold their data in a safe manner and use it in a confidential manner with the benefit that can be used by the industry as a whole. So a number of projects ongoing, and we encourage our participants and our partners and in the industry and beyond to come and talk to us. You can approach us through our website. Certainly we are having a number of conversations, and we're welcome to hear from you how we can help you.
Okay, that's great, Pamela. Actually, you have answered another question that we have had. So I am trying and I will wrap up with the last question. And it's around how to interact with the NDC. So is the technology available for a company to use, i.e. if a company had a vessel operation or a technology they would like to model, how will they engage with the NDC? So I'll maybe go to Sergey first.
Yeah, thanks, Karen. Yeah, I think they should get in touch with us, send us an email and look at this individually. We would be happy to have a look at the requirements. We've got a library in the simulator where we can use vessels, ROVs, birds, all type of offshore assets. So we could do that, absolutely. Yeah, please write us an email and to discuss this further.
And Sergey, maybe just to finish off, it says, what type of real-time data can the simulator collect and process? Can current technology automate the decommissioning processes?
Well, I think this is where we are going. So we don't have anything automated yet, but that's what we want to achieve. So when we talk to satellite live data, we could be talking about vessel positioning or traffic or even energy output in megawatts from different production facilities. But we are getting there. We need to gather all the data first, and then find ways through algorithms and so on to understand this data and get an output from it. If anyone can have anything else to add.
I think we'll wrap up there. Thanks, Sergi. We are just beyond time. I just want to reassure all the our online guests and those that have asked questions. We will answer your questions if we didn't get to them in this session. I'd like to thank you for joining us online and for your questions, and I hope you found it useful. Contact details will be put up after we finish this Q&A session, so please get in touch with us directly here at the National Decommissioning Centre. I would like to thank our panel for their really discerning answers, and I think we can now finish the session. So the session has closed. Thank you all very much for joining us. It was a pleasure to have you, and goodbye, and we hope to see you all soon.